Hello friends, my name is Munagar Vimal. Here I am going to take Mathematics of Standard 9. I will teach you chapter 2, Polynomials. In this chapter, we will study the topics Introduction of Polynomials, Types of Polynomials, and then we solve the exercise number 2.1. First of all, we get Introduction of Polynomials. Here, you know, you have studied all algebraic expression and their addition, subtraction, multiplication and division in earlier classes. From them, some of the algebraic identities are given below that you have already studied. Here x square x plus y all square is equal to x square plus 2xy plus y square. X minus y all square is equal to x square minus 2xy plus y square, and x square minus y square is equal to x plus y into x minus y. These all are algebraic identities which you have studied in earlier classes. In this chapter, we are going to study with a particular type of algebraic expression which is called polynomials. Yes, we will use algebraic identities and algebraic expression to understand polynomials. Here, in mathematics, there are many type of polynomials, but here we will study only polynomials in one variable. Now, first of all, I will teach you, or we will study about variables. What is a variable? A symbol that can take any real value is called variable, or any of symbol that can assume any type of number or a real value, then it is called variable. To describe or to denote variables, we use the letters x, y, z or abc to denote variable. Now here some algebraic expression are given as below, that is 2x, 3x, minus x, minus half x. These all are algebraic expression that you have studied. Now here you can see that the given algebraic expression are in some form, that is all algebraic expression are of the form as given a constant multiplied by a variable. You can see here the all algebraic expression are given in such a form, a constant multiplied by a variable. Here you know that the value of constant do not change in any given problem, that it always remains as it is, it will never change. But the value of variable can keep changing, because it will varies in every problem, and it takes real values, then it will keep changing. Now from all of these, you are also familiar with given algebraic expression, which are 2x, x square plus 2x minus x cube plus 4x plus 7 are called polynomials in one variable. Here you can see that in 2x we have used only one variable x. In x square plus 2x, here also we have used only one variable x, and another example we have also used only one variable as a now more example given here. One, my x cube minus x square plus 4x plus 7 is polynomial in x. 3y square plus 5y minus 7 is polynomial in variable y, and 5t square minus 60 is polynomial in variable t. Then it was about variables, and from that all the examples are in one variable. Now, how can we conclude and consider that all algebraic expression are polynomials or not? Then we have to note here that algebraic expression we have considered so far only whole numbers as a exponent of variable. In polynomials, the exponent of variables always be whole number, and this type of expression are called polynomials in one variable. Then other example, here we can see that here given example x cube plus 2x, we have we can see that here in x, here we have used whole number as a exponent. Then this this example is this algebraic expression is known as variable polynomial in one variable. Then another example, x raised to minus 1 plus 1. Here minus 1 is not whole number. Then we cannot say that this example, this algebraic expression is polynomial. The another example, 5 5x raised to 3 by 2 plus 2x minus 7. Here also x has the x has not a whole number. Then we cannot say that given example is polynomial. Now some other symbol that we study here in polynomials, x square plus 2x. The expression in polynomial x square and 2x are called terms of the polynomials. In polynomials, this type of expression all are known as terms in polynomials. Now, in polynomials, here one given example of polynomial minus x cube plus 4x square plus 7x minus 2. Here you can see that each term of the polynomials has constant value, and it is called coefficient of terms of polynomials. Here every variable has a constant value, and it is known as coefficient of terms of polynomial. For example, here we can take a term minus x cube has a coefficient, the a constant value minus 1, and in 4x square has coefficient 4. So in polynomials, a constant value in polynomials are known as a coefficient of terms. We shall denote the polynomials by p of x, q of x, r of x, or d of x. In polynomials, we will use such type of expression to denote polynomials. Here given examples, p of x is equal to 2x square plus 2, and q of t is equal to 9t cube minus 60 plus 1. Then it is all about polynomials. Now we will study the types of polynomials. In this chapter, we will study only two types of polynomials in one variable. That is, first type, the types of polynomials according to terms in types of polynomials according to terms in polynomial. The first type is that according to terms, and the and another type, the types of polynomials according to degree of polynomial. Then we here the first type, the types of polynomial according to terms in polynomials. Here we will see in polynomials that how many terms are given in polynomial, and then we describe it as a polynomial, the types of polynomial. Here shall we study four types of polynomials as a given below. The first one is zero polynomials. How can we say that the given polynomial is zero polynomials? The constant polynomials is known as zero polynomial. A constant values as a 2, -5, -half, 7 are known as zero polynomials, because here uh, we can see that here the values are constant, then it is zero polynomials. The another one is monomials. When polynomial having only one term, polynomial that have only one term are called monomials. Here in polynomials, here given some example: 2x, 5x cube, -5x square, y, and u raised to 4 are called monomials, because in these all polynomials there exists only one term in polynomial, then this called monomials. These are two types of polynomials according to terms in polynomials. The other one, binomial. Binomials. Polynomial having two terms are called binomial. In polynomial, if we find two terms, then are called binomials. Here given some example: p of x is equal to x plus 1. You can see that in this polynomial there are two terms, x and 1, then it is called binomials. In other example, q of t is equal to t square minus 1. Here also two terms, then it is called binomials. And s of y is equal to 9y square minus 2y. It is also binomial, because there are only two terms in given example. The fourth type, trinomials. Polynomials having three terms are called trinomials. In polynomial, if there exists three terms, then we can say that the given polynomial is trinomials. Some examples: q of t is equal to t cube minus 2t minus 1. Here you can see that there are only three terms in given polynomial: t cube minus 2t minus 1. Then it is called trinomials. And another example, p of x is equal to 9x square minus 2x minus 2. Here also three terms, then it is called trinomials. So these are types of polynomials according to terms in polynomial, which are: the first one, zero polynomial; the second one, monomial; then third is binomial; and the fourth is trinomials. These types according to terms in polynomials. Now we will study the types of polynomial according to degree of according to degree of polynomials. Now, first of all, we have to understand what is a degree of polynomial. Then the degree of polynomials, we call we call the highest power of variable in polynomial the degree of polynomials. Here in polynomials, the highest power of variable, and it is called degree of polynomial. Now, one thing that we have to note, the degree of a non-zero constant polynomial is 0, as we have already studied zero polynomial, that is p of x is equal to 2. It is a constant polynomial uh, which is written as 2x raised to 0. We know that the we know that the power of any variable is 0, then it is equal to 1, equal to 1. So the exponent of x is 0. So here the degree of given polynomial is 0. So it is about it is about degree of polynomials. Now from this we will study the types of polynomials according to degree of polynomials. Now here some example given as below. Then we will find the degree of polynomials. Here given first example, x raised to 5 minus x raised to 4 plus 3. Here highest power in this polynomial is x raised to 5. Then the degree of this polynomial is 5. The another example, 2 minus y square minus y cube plus 2y raised to 8. Here the highest power of variable is y raised to 8. Then the degree of polynomial is 8. Here as we learn 2. Here we can see that x raised to 0 is equal to 1. Then here the degree of polynomial is 0. And 9x raised to 151 plus 2x raised to 150 plus up to 1. Here the highest power of polynomial is x raised to 151. Then degree of polynomial is 151. So this was about degree of polynomials. Now we will study the types of polynomials according to degree of polynomials. The first one is linear polynomial. A polynomial of degree 1. If polynomial has only 1 degree, then it is called a linear polynomial. A polynomial of degree 1 is called a linear polynomial. We will describe all linear polynomial in general form as given ax plus b. General form of linear polynomial is ax plus b. We describe all linear polynomial as ax plus b, where a and b are constants as we know, and here we note that a is not equal to 0. A never be 0. The the variable having degree 1 and its coefficient never be 0, then it is called linear polynomial. Some example are given here. P of x is equal to 2x. here you can see that the x has only degree 1, then it is linear polynomial. Another example, q of x is equal to 9x minus 1. Here also you can see that the x has only 1 degree, then it is also called uh, linear polynomial. And another example, s of y is equal to 2y minus 2. Here also there is 1 degree of polynomial, then it is called linear polynomial. Now the second type, quadratic polynomial. A polynomial of degree 2 is called quadratic polynomial. If any polynomial has degree 2, then it is called quadratic polynomial. We describe all quadratic polynomial in general form as ax square plus bx plus c. This is form of quadratic polynomial. Now, and where ABC are constants, and here a never be 0. A is not equal to 0. If here we put 0 as a, then it vanish the first term of polynomial, then remains bx plus c. It is the form of linear polynomial, then it never be, we cannot say that the given form is quadratic polynomial. So we have here we have to note that a never be 0. Some example are given as below. P of x is equal to 2x raised to 2 minus 2x plus 2. It is quadratic polynomial. And q of y equal to 9y square minus 6y plus 3. Here you can see that x has the highest power 2, and it is the degree of polynomial, and the degree of polynomial is 2. Then we can say that the given examples are example of quadratic polynomials. Now the third type, cubic polynomial. A polynomial of degree 3. If polynomial has degree 3, then it is called cubic polynomial. Now we describe all cubic polynomial in general form as given: ax cube bx plus bx square plus cx plus d. It is the general form of cubic polynomials. And a, b, c and d are constants, and a is never be 0, is not equal to 0, because if you put here a equal to 0, then the first term will vanish, then the remaining part of polynomial is bx square plus cx plus d, and it is form of quadratic equation. Then if we will put here a is equal to 0, then it never be cubic polynomial. So we have to note that a is not equal to 0, a never be 0. Some example are given here. P of x is equal to x cube minus x square plus x plus 1. You can see that the highest power of the given polynomial is x cube. Then the degree of polynomial is 3, and the degree of polynomial 3, then we can say that the given example, the given polynomial is cubic polynomial. Another one, q of x is equal to x cube minus 1. Here also we can see that uh, x has power 3, then it is called cubic polynomial. Now these are types of polynomials according to degree of polynomial. Now if we want to describe a polynomial of degree n. If we want to write polynomial of degree n, then its formula is an x raised to n plus an minus 1 x raised to n minus 1 plus up to plus a1 x plus a0, where a1 a0 a1 up to an are constants, and as we know that an never be 0, or an is not equal to 0, then we can write any type of polynomials of degree n as given formula. This was about the types of polynomials. We have studied here two types of polynomials according to terms in polynomials, and other one is uh, degree of polynomials. From all of these, now we solve the exercise number 1. Now here given first question, which of the following expression are polynomials in one variable and which are not? State reason for your answer. So first example is given 4x square minus 3x plus 7. Now we have to say that the given example is polynomial or not, and have to state the reason. Here you can see that the exponent of each term is whole number. You can see that x for the first term 4x square has whole number exponent, minus 3x has also exponent as a whole number. Then we can say that the given example is polynomial. The given algebraic expression is polynomial. Another one, y plus 2 by y. Now this algebraic expression we can also write as a y plus 2y raised to minus y. So here you can say that the exponent of second term, is not whole number. It is not whole number. Then we can't say that the given algebraic expression is polynomial. The rest of examples you can solve by yourself. Now we will go to next question. Here given the question 2, write the coefficient of x raised to 2 in each the following example. So here the first example, 2 plus x square plus x. We find the coefficient of x square. Here you can see in this polynomial the second term, x square, their coefficient of x square is 1. And now the second example, 2 minus x square plus x cube. The coefficient of x square is minus 1. Here third example, pi by 2 x square plus x. Here the coefficient of x square is pi by 2. Fourth one is root 2x minus 1. The coefficient of x square is 0, because here x square is not given. So the coefficient of x square is 0. Now the third question, give one example each of a binomial of degree 35 and of a monomial of degree 100. 100. Here a binomial of degree 35 is p of x equal to x raised to 35 minus x square. You can take any example, but uh, in that example you have to put the highest power as a 35, and also you have to note that the term has whole number of exponent. The another answer, a monomial of degree 100. We know that in polynomial, if there is only one term, then it is called monomial, and you can use any variable to describe monomial. Here I have used q of y equal to minus y raised to 100. Then it is called monomial, and it is example of monomial. Now question number 4. Write the degree of each of the following polynomials. We know that the highest power of polynomial is known as the degree of polynomial. Now we find the highest power in polynomial. In first example, here 5x cube plus 4x square plus 7x is given. Now you can see that in this polynomial, the first term 5x raised to cube has the highest power 3. Then the degree of polynomial is equal to 3. 4 minus y square. Then highest power of this polynomial is 2. Then the degree of polynomial is 2. Third one, 5t minus root 7. Here also the highest power of given polynomial is 1. Then degree of polynomial is 1. Third one is 3. Then degree of polynomial is equal to 0. We know that if here not given any variable, then we can assume that the x or any variable has power 0, then it is equal to 1. So the highest power of this polynomial is 0. Then the degree of polynomial is 0. Now last and uh, question number 5. Classify the following as linear, quadratic, and cubic polynomials. We know that a polynomial has 1 degree, then it is called linear polynomial, and it has degree 2, then it is called quadratic polynomial, and if it has degree 3, then we can say that the given example is cubic polynomial. So now here you can see that in first example the degree of polynomial is 2, then we can say that the given example is quadratic polynomial. Another one, second one is x minus x raised to cube. Here the highest power is 3, then degree of given polynomial is 3, then it is called cubic polynomial. Third one, y plus y square plus 4. Here you can see that the highest power of a given polynomial is 2, then this example is quadratic polynomial. Fourth one, 1 plus x. Here also the degree of polynomial is 1, then it is known as linear polynomial. Fifth example, 3t. Here also degree of polynomial is 1, then it is called linear polynomial. In example 6, there is degree exponent of r is 2, then degree of polynomial is 2, and it is called quadratic polynomial. And last one, 7x raised to cube, then here the degree of polynomial is 3, then it is called cubic polynomial. So this was solution of exercise